This will be our second venture into graphing quantitative variables. We want to look at a little bit of a summary of what we do with graphing, how we analyze it up to this point, and then also look at two examples of how we do it. We've already talked about dot plots. Here we'll talk about stem plots and also histograms. So first of all, just a note that this is introductory. We will do more in-depth work with some of these ideas later and get more precise pieces of measurement. But to start with, we look at when we talk about these graphs of the data sets, we discuss the shape. We've talked about left skewed. We've also talked about symmetric graphs, the mirror image ones, and a specific symmetric graph that we've talked about is uniform, a uniform distribution that's pretty much the same value all the way across. And then we talked about right skewed. Now left and right skewed you have to use some insight for because oftentimes people get it wrong. Left skewed goes with the left tail. This tail is on the left side and then the mountain of the data is on the right. Whereas right skewed, instead we have the mountain on the left and then the tail of the data goes off to the right side. So right skewed, right tailed, left skewed, left tailed. So the center of this is, we've been using either the mean or median. Most of the times we've been using the median. We'll use the mean oftentimes more often later. The variability, what we've been discussing is listing the min and the max value. Later on, we'll be talking about other measures of variability as part of things like standard deviation. And then we talk about outliers. Outliers, you want to list those. If there's a value that's outside of what we would expect with this distribution, then we list that as an outlier. What is the pattern of the graph? Is there a value that's outside of that pattern? All right, now let's talk about a specific type of graph for quantitative variables, a stem plot. The stem plot is a little bit different than others. It turns the graphical representation on the side, and it goes with a vertical axis on this. So it shows each value separated into two parts. The first part is the stem of the graph. The stem of the graph is the left digits in a number. In essence, it's all digits except the last one. That's because that last digit will list as what's called the leaf. So it is the final digit. This will give us an idea of what the shape of the graph looks like. When we do this, we want to list it in order. So list these in order. And we're going to list them vertically. You're going to put, it's going to be with a segment between the stem and the leaf. Okay, so as we look at this, let's look at some specific directions for this. You're going to make the stems first. All but the last digit is the stem, the last digit is the leaf. So smallest to largest without skipping blanks. If you do have a missing interval number, you still list it as part of the stem. So if you got numbers 60s, 70s, but there's no 80s and then 90s and 100, you go ahead and list that missing one as well. It just will be with no leaves on it. Add leaves after the vertical line, keep them in order, and provide a key to provide context. Okay, so here's two examples. The examples here are cars in parking lots. So we're going to start with the south lot here. So my south lot, when I do this, I'm going to look at these numbers and I'm going to start with the smallest. The smallest number is 63, my largest is 108 in this. So I list the first digits, so leave off the last one. So I'm going to list 6, 7, 8, 9, and 10, and put a vertical line next to it. Now after that, I put the ones, the last digits. So I like to cross them off when I find them. So 63 is my smallest. Then I've got 68 as my next one. So those are the last digits of two of the numbers. So stacked, I'm not using the number 38. This tells me this is 63 and 68 as a number. And then I keep going. I've got my next one is 71. And then my next number is 76. So cross that off. And then two 77s. So just list those last digits. And then in the 80s, I have an 85. It's my next one. And then I've got 87 and 88. That's my next number. And then lastly, I've got 90, so I'll put 90, and 108. The 10 is the stem, the leaf is just the 8 for it. Now, I'll put a key here to describe what I have. This key will describe both of them since they're similar. So 85, 8 with a slash and a 5. So this one here, what that means, 85 cars in the lot. So this is my key to this information. It tells me what's happening with this. Now let's go ahead and write our summary information about this. Now when you look at this, you got to look kind of sideways to get if it's symmetrical, left skewed or right skewed. Or you could think for skewness, you could think this is skewing toward the positives. As I go further positive, that's where the tail of it is. So it's positively skewed. So that would give me a right skewed distribution. This is right skewed. Now I want to get the median. Remember, median is the middle number. There's 11 numbers in this list, so I'm going to count 5 in, and the 6th one from either direction will be my median. So if I count 1, 2, 3, 4, 5, 6, 77 is that middle number. Now if I count from the top, notice I have to do 1, 2, I've got to go to the top because I'm going with bigger numbers. So 1, 2, 3, 4, 5, 6, if I'm counting from the larger numbers. And then lastly, I'm going to list, and this is, by the way, 77 cars, so we want to give the context. So my minimum number of cars is 63 cars. So put the label on it. And the max is 108 cars. So give the context for your graph. Now let's do this example. You might want to, if you want to try it out, just pause the video and you try it and then check with what I come up with. So this is in the north lot. The north lot, my lowest number on this one is 88. So I'm going to start with 8 and then go 9, 10, 11, and 12. I go up to 120. I've got 120s, a couple of them. And so that's my largest. I've got a few of them actually. And so when I look at those, I go ahead and draw a line after that because those are my stems. Now the leaves. If you go through this list and cross off the ones, I have just an 88, I've got a 94 and a 95, I've got a 103 and a 107, I've got a 111, another 111, so you list them both, and a 113, and then I've got a 121 and 125 and 128. So if I look at this distribution, it looks like it's skewing toward, in this side, I've got the mountain on the right it's skewing toward the left. The left is a left tail to it. So this would be left skewed toward the negative. Okay, going the negative direction. Then my, if I count for my median, again, sixth one in, so 1, 2, 3, 4, 5, 6, 111 cars is the median. And then I talk about the min and the max. So the min for this one is 88 cars, and the max is going to be 128 cars for it. So that's a stem plot, sometimes called a stem and leaf plot. Now we can put these together and do a back-to-back stem plot to compare these. If we want to do a comparison, which we can do here, we can compare these two and say, oh, it looks like the median of this one, 111, is larger than the median of this one, 77. And I can also see that this one, their skewness is different. But looking at a comparison back to back will help us take a look at that. So if I look, and I've got the south, I'll do on this side, I'll do the north on this side. I'm gonna put the stems in the middle. So my lowest stem for both of these is 6, my largest is 12. So I'm gonna do 6, 7, 8, 9, 10, 11, and 12. I'm gonna put a line on this side and a line on this side to separate from the leaves of this. Okay, so now let's go ahead and list it. Now the easy one is to do the one on the right. I'm gonna just list it as is. So this would be, you put an 8 here, a 4 and a 5, and then I do a 3 and a 7 for the 103, 107, and 111, 111, and 113, and then 1, 5, and 8 for these leaves on this side. So that gives me the north side. Now let's look at the south side. Now this one you gotta go backwards. So when I have a 3, 8 here, I'm gonna go out from the 6 and go 3 and 8. I'm gonna go 1, 6, 7, 7. I'm gonna go 1, 6, 7, 7. So instead of going left to right, I'm doing right to left on this, building it out from the middle. Okay, 5, 7, 8, build it out, 5, 7, and 8. And then for the 9, I just have a 0. And for the 10, 108, I just have an 8. So now you can see a comparison. This north one definitely looks like it's shifted toward the positive. So I have a lot more values in the positive direction here. So you know, a comparison. Okay, you've got a larger median. It would be 111 cars for the north lot. And the north is skewed it's got a left skew to the left, got a lot more values to the right. The south is skewed to the right. You talk about variability, you could talk about the fact that the minimum here is much less than the minimum there, and the maximums also, you have a larger maximum on the north side. Okay, so that would be how we do stem plots, and we discuss them. Let's go ahead now and look at histograms. Now histograms you may have seen before, they look a lot like bar charts, just don't get them confused. Bar charts are for when we do categorical data. Histograms are done when we do quantitative data. So histogram quantitative data grouped into intervals displaying the frequency or relative frequency as a bar. So this is useful for larger data sets. It would be hard to do a dot plot or a stem plot with large data sets. This allows you to put things into groupings, so useful for larger data sets. And then histogram also has no gaps between bars. Now there is a caveat or an exception to this, unless an interval has no data. So if there's no data, you're going to leave a blank interval there. You don't want to skip intervals, and so you might have blank one. All right, so graphing instructions. Equal width intervals, that's very consistent in how we've been doing our graphs. You want to use at least 5 bars, 5 intervals for this. It's a good minimum. You could do more. Make a frequency table or relative frequency table. Any value on an interval boundary goes into the larger one. So like the number 90, do I put that in from 80 to 90 or from 90 to 100? You always bump it up to the larger one. So 90 is right on the boundary between the 80 to 90, 90 to 100, put it in the 90 to 100, bump it up. Okay, draw and label the axes, use a scale to match the intervals, and draw the bars. All right, so a couple details that you should know of. The choice of intervals, how many intervals you choose, can influence how you see the distribution. So it can affect the appearance of the distribution. This is part of the art of doing statistics, is sometimes how you choose things can make it look differently. Okay, so just be aware of that does happen. Also, in comparing distributions, use relative frequency. Now, I didn't do that with the last one because it had exactly the same number of data points. But if you have far fewer data points in one, using a histogram, it will stack shorter than one with a lot of data points. So it might influence your viewing of it. So if they have different numbers of data points in it, use relative frequency. That will kind of even it out. And then lastly here, bar graphs and histographs look similar. Just remember, a bar graph is for categorical data. And also it has gaps between bars. Whereas histograms, they look similar to this, but histograms are for quantitative data. And then for this one, you're going to have adjacent bars. The only time you're going to have gaps is if there's no data in an interval. So the bars are usually right next to each other. Let's do an example. I'm going to just use the same data set I had before, but I'll just use the cell plot for this example. So this is the same data we had before. So I want to set up a frequency table here. So I want to talk about my interval and then the frequency with which that happens. So the interval I'm going to describe, notice, remember the lowest number was 60, so I'm going to go in intervals of 10. So I'm going to go from 60 to less than 70. I'm actually be very specific. That's going to be less than 70 for this. So there's 2 numbers in that category. 70 to less than 80. There are 4 of those. And then 80 to less than 90. There are 3 of those in this data set here. And then from 90 to less than 100, there's only 1 of those. And then from 100 to less than 110, there's only 1 of those items. So let's draw a histogram now. So I'm going to go up to, my frequency only goes up to 4. So we go 1, 2, 3, and 4. And over here, I'm going to go by 10. So start at 60. You don't have to start at 0 on this. You start at a convenient number. So 60, 70, 80, 90, 100, and 110. And so this first bar is going to go up to 2. So we go from 60 over to 70 up at 2. Then we can go all the way up to 4. Now notice that they share a side. They're adjacent to each other, so there's no gap between them. And 70 is its boundary point, so we're right up next to each other. So from 80 to 90, I'm going to be at 3. So draw that one. From 90 to 100 and 100 to 110, I'm at 1. So I'm going to draw 2 bars there at those points representing the 1. When I look at this and I analyze it, it's going to be the same analysis I had for the stem plot for this. This is right skewed, okay, because the tail is on the right side. I'm going to have a median of 77. I got to look back at the data to find that. But 77 right here kind of makes sense. It kind of looks in the middle of my graph. 77 cars is the median. 63 cars is the minimum. 108 cars is the maximum. So we've looked at quantitative data and we've taken the time to describe how we do 2 types of graphs, stem plots and histograms, and how they represent our data sets.